We continue now our visit to southeast Oklahoma. Here's Austin Moore with a story on Pinemap research.
Plants provide many obvious benefits to people. However, some of their gifts, while important, are more subtle to the eye. Oklahoma State University research specialist Randy Holeman explains.
As photosynthesis takes place, the tree is absorbing carbon dioxide, and in the process it releases oxygen. So basically it's taking the carbon out of CO2 and releasing the O2 back into the atmosphere. You know, anything that comes from hydrocarbons, fuels that we burn, things like that, things that we look at as pollutants. Anything these trees pull out of the atmosphere that we consider pollutants. That's one of the benefits of plantation management, pine plantation management, is that because it's so actively growing, it does a lot of carbon sequestration.
Those effects, along with efficiency and sustainability, are the focus of a 5-year, $20 million research project being conducted throughout the southern United States, known as P.I.N.E.M.A.P.
Our overall goal is to increase carbon sequestration by 15% and increase the efficiency of fertilizer application by 25%. So in other words, we're looking to increase growth, increase the positive benefits of forestry by taking more CO2 out of the atmosphere, and to reduce the cost of management in terms of the fertilizer application. In Oklahoma, our main focus is to look at the effects of rainfall reduction in a scenario that might represent a future drier climate.
As we see changes in climate, whether it's long-term or just, climate cycles, things like that, it's going to show us what loblolly pine does and how it responds to different climatic conditions it might encounter.
If you look at the southern United States, it's a carbon sequestration basket for the United States, and roughly about 16% of the carbon that's sequestered in the United States is sequestered in the southern United States forests. Okay, and what we're looking at doing is looking at trying to figure out the impact of global climate change on that sequestering, how we can impact and increase sequestering of that carbon throughout the plantations and the forests of the southern United States, and also increase the efficiency of our silvicultural practices in there, fertilization, those types of things. So that's the gist of what we're trying to do.
So looking at all of that, why is then, as we look at the southern United States, why is Oklahoma such a great place to be doing that research?
Good question. Oklahoma's, most people don't think of Oklahoma as a timber state, because our timber's sequestered in the southeast counties and the eastern counties of the state. But in reality, what's happening is we're on the very fringe of the southern pine belt. Okay, you go a little bit further west of here and pine disappear. So what we're actually doing is in Oklahoma, we can actually simulate some of the environmental conditions that are going to be occurring potentially throughout the South with the decreased amount of rainfall, the infrequencies of the thunderstorms and the rain events we have here. So Oklahoma is a great place to do this kind of research. We're kind of on the cusp of what might be considered global climate change in the southern United States.
The USDA-funded Pinemap project involves research teams from 11 land-grant universities, 8 research cooperatives, the U.S. Forest Service, and the Southeast Climate Consortium. It is an impressive coalition of scientists and educators and is already generating a mountain of data. The figures from the Oklahoma portion of the project alone are astounding.
The data we downloaded today was from about the last month and a half, and there were over 1 million values collected off of one replication. The biggest part of the data that's collected here comes from sap flux probes in the trees themselves. What that's made up of is 2 thermocouples inside the tree there with a heater on one and the other's unheated. And as photosynthesis takes place, it actually changes the temperature of the sap that's flowing through the trees and the conductive tissues there.
I asked graduate assistant Cassandra Meek to show us some of the data collection tools being used.
This is a LICOR portable photosynthetic system, and we can actually measure CO2. We can measure the release of CO2 if we're interested in respiration, and we can also measure the uptake of CO2 if we're interested in photosynthesis. Right.
All right, now let's talk about what else you're measuring out here. I know there's a lot of tools.
Yes, we are also measuring light interception
Okay.
And basically what this little wand does is it measures just photons of light. So what we'll do right here is I'll go into a sunny area and I'll take measurements at the 4 cardinal angles of full sun, and then I'll come in and I'll measure. I'll just try to get a representative measurement all throughout the plot, so some under, some out here. And then what we basically do is we'll subtract those values from the full sun to let us know how much of the canopy has picked up light.
We'll mine that data for specific relationships related to temperature, humidity, solar radiation, and soil moisture, and be able to really fine-tune some estimates of local Oklahoma productivity levels based on changing those environmental parameters. Then we're using this as a research platform to conduct some Oklahoma-specific research. In particular, we're looking at water use, we're looking at stand dynamics and canopy development, and also at the gas exchanger, the photosynthetic rates as it relates to the drier environment.
And that gives Will reason to believe that this research will directly impact Oklahomans.
You know, with 30 million acres of pine plantation southwide and 1.5 million acres approximately in Oklahoma alone, which in fact supports a $1 billion per year industry in Oklahoma, I feel confident our research will have a real positive effect on the environment as well as on the bottom line of pine plantation management.